Hello children, welcome to my channel. This is Rectilinear Figures part 5. This is the last part of the theorems. Okay, the chapter will not be over. I will make one more part for this chapter. This part 5 will be based on the theorems of square. Okay, already I have started the theorem for square in chapter part 4. It was theorem number 10. The theorem was like this. If adjacent sides of a rectangle are equal, then it is square. It was theorem number 10, which I had given in part 4 in the previous part. Okay. Now I will give all the remaining theorems of square. There will be 4 theorems. Okay. Theorem number 11. Okay. All are based on squares. Theorem number 11. If diagonal of a rectangle bisect the vertex angles, okay, if diagonal of a rectangle bisects vertex angles, it is a square. In a rectangle, diagonals do not bisect the vertex angle. Okay, if they bisect vertex angle, then it is a square. We will prove this. Okay, so let us draw a rectangle so that its diagonal will bisect the vertex angle. This is A, B, C, D. It is already rectangle, so we will give 90-degree sign, right angle sign. All angles are 90 degrees. Then if diagonal, both diagonals we don't need, one diagonal is sufficient. Let us draw AC. Let us draw AC. Suppose it is given that it bisects the vertex angles. Okay, this is equal to this and this is equal to this. Okay, we will prove that it is a square. So given ABCD is a rectangle, each angle is 90 degree. Okay, then AC bisects angle A and angle C. As you can see in the diagram, AC bisects angle A and angle C. We will prove that it is a square. ABCD is a square. Okay. So how to prove that it is a square? Already it is a rectangle. If anyhow we are able to prove that adjacent sides are equal, it will become a square by theorem number 10. In theorem number 10, I had given that if adjacent sides of the rectangle are equal, it is a square. Okay, so we will try to use theorem number 10 here. Okay, so now let us go to proof. Angle A is equal to angle C. Each 90 degree, angle BAD or angle A is equal to angle BCD is equal to angle C. Both are 90 degree. Okay. So half angle A is equal to half angle C if they are bisected. In place of half angle A, we can put CAD or CAB. We can take any of these two angles. Let us take CAD. Last time there was a theorem like this in parallelogram. If diagonal of a parallelogram bisects the vertex angles, then it is a rhombus. Okay, there was a similar theorem. Okay, so in that theorem we have taken this angle. Now let us take this angle. So angle CAD is equal to half of angle C means either angle DCA this one, okay, or angle BCA this one. Last time we have taken this one, so let us take this one this time. Okay, angle BCA, this one, angle BCA. Why? Because a C bisects angle A and angle C. Okay. Now if you look at this triangle, two angles are equal. Don't look at this triangle. Look at this triangle which I have marked, cross sign I have given. If two angles are equal, then two sides will be equal. This is a theorem from isosceles triangle. You might have studied in lower class. In this class 9, it is now out of syllabus. Okay, but you have to understand but you read the theorem. If two angles are equal, then the opposite sides will be equal. So the side opposite to angle CAD is CD. The side opposite to angle DCA is AD. CD is equal to AD, means this side is equal to this side. Okay. Why? Sides opposite to equal angles. This is the theorem which is out of syllabus now, but you need it. Okay. So CD is equal to AD, but there are adjacent sides of the rectangle. Okay. But they are adjacent sides of the rectangle. This is ABCD, okay? But they are adjacent sides of the rectangle ABCD, so it is bound to be a square. Using theorem number 10, okay? Already it is a rectangle, adjacent sides are equal, so it is a square. Hence proved. This is theorem number 11. Next, theorem number 12. Again based on square. Theorem number 12. Okay. Theorem number 12. This was based on angle. Now let us move to diagonal. Okay. If diagonals of a rectangle diagonals of a rectangle are perpendicular to each other, then it is square. Okay. So actually in a rectangle diagonals are simply equal and they bisect each other, but they are not perpendicular to each other. But if they are perpendicular to each other, then it will become a square. Okay. So let us draw a rectangle. Let us draw a rectangle in which diagonals will be perpendicular to each other. A, B, C, D. Since it is a rectangle, so I am giving right angle sign. Each angle is 90 degree. We have to draw diagonals also which are perpendicular to each other. AC, BD. Suppose this is O. The point of intersection of the diagonals is O. They are perpendicular to each other. Okay. So we are going to prove that it is a square. Again, we will try to use theorem number 10. You can see already it is a rectangle, each angle is 90 degree. Just we have to prove that adjacent sides are equal. Okay, if adjacent sides are equal, then it will become a square. So to prove that adjacent sides are equal, you have to take any two adjacent triangles, either these two or this two or this two or this two. Let us take this and this, AOB and AOD. Okay. So first given ABCD is a rectangle, as you can see given. Okay. Then AC perpendicular to BD, this is also given. To prove ABCD is a square. Okay. Then we will go to proof. Then we will go to proof. In triangle AOB and triangle AOD. Look at these two triangles. Okay, we will try to prove congruency. Okay, so OA is common, as you can see. OA is common. OA is equal to OA, which is common. You can see in the diagram. Angle AOB is equal to angle AOD. This angle is 90. This angle is also 90. So we can write each 90 degree. Okay. Then OB is equal to OD. OB is equal to OD because we know that in a rectangle diagonals bisect each other. Okay. Diagonals of a rectangle bisect each other. Okay. So now you can easily get the order. AOB congruent to first target angle. AOB means O, AOD means O. O corresponds to O. So O middle means O middle. Okay. O middle means O middle. Then no more angles, so target sides now. OA. Opposite of OA is B. Opposite of OA is B. So B corresponds to D. So B last means B last. What is the last option? A. This is side angle side. Side angle side. Okay. So now you can write AB is equal to AD 1313. Okay. AB is equal to AD. So we got AB is equal to AD. But they are adjacent sides of the rectangle. Okay, these two are adjacent sides of the rectangle, so it is a square using theorem number 10. Okay, so now you can write ABCD is a rectangle. Okay, and AB equal to AD, which are the adjacent sides, so it is a square using theorem number 10 here. Next, theorem number 13. Now, in this theorems for a square, theorem number 10, theorem number 11, theorem number 12, these three theorems we got square from rectangle. Okay, first was if adjacent sides are equal, then it is a square, means adjacent sides of rectangle are equal, then it is a square. Then second theorem for square, if diagonal of a rectangle bisect the vertex angles, then it is a square. Third theorem for square from rectangle, if diagonals of a rectangle are perpendicular to each other, then it is a square. So from rectangle to square it is over. Now we will move from rhombus to square. Okay. Rhombus to square, theorem number 13. Theorem number 13. Theorem number 13. Rhombus to square. The difference between a rhombus and a square is not in the sides. In a rhombus all the sides are equal, in a square also all the sides are equal. The only difference is in their angles. A rhombus is bent, a square is straight. That is the only difference. So we can have a theorem like this. If one angle of a rhombus is 90 degree, if one angle of a rhombus is 90 degree, then automatically each angle will become 90 degree and it will be a square. It is a square. Okay. So let us draw a rhombus in which one angle is 90 degree. A, B, C, D, all the sides are equal because it is a rhombus. Okay. One angle is given 90 degree. Suppose let us take angle A is 90 degree. Okay. We are going to prove that it is a square. How to prove that it is square? If each angle is 90 degree, then it will become a square. Already the sides are equal. Just we need the angles. Okay. So let us move to the angles. Given ABCD is a rhombus, it is given angle A is 90 degree. This is also given. To prove ABCD is a square. Okay, this is our target. So let us go to proof now. Let us go to proof. Angle A is equal to angle C. Look at the figure, angle A is equal to angle C. Why? Because opposite angles of rhombus are equal. Opposite angles of a rhombus are equal. Okay, are equal, you don't need to mention, simply this is right. Opposite angles of rhombus, this is sufficient. Okay. So if angle A is 90 degree, then angle C is also 90 degree. So both are 90 degree. So now we got angle C is also 90 degree. But this is not sufficient. We have to move to angle B and angle D also. Next, angle A plus angle B is 180 degree. Why? Aligned angle. In a rhombus, all the sides are equal. Okay. Let us take the opposite sides. Okay. Suppose AD and BC, they are equal. Also, they are parallel. I have given this property in part 2. In part 2. Okay. I have given this property in part 2. So opposite sides are equal and parallel. All the sides are equal and opposite sides are parallel. So we can say AD is parallel to BC. If AD is parallel to BC, then angle A plus angle B should be 180 degree because they are allied angles. Okay. What is angle A? 90 degree plus angle B is 180 degree. This implies that angle B is equal to 180 minus 90, which is 90 degree. Okay. So we got angle B is also 90 degree, but angle B equal angle D. Opposite angles of the rhombus. Okay. Opposite angles of a rhombus are equal. So if this is 90, this is now what we get? Already it is a rhombus, means all the sides are equal as you can see, plus each angle is 90 degree. So it is a square. Okay, hence it is a square. So you can write like this, and the proof part only. AB is equal to BC is equal to CD is equal to DA. Sides of the rhombus. Okay, all the sides are equal. Then angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degree. Okay. Here I am 90 degree. This is already proved. Okay. So all the sides are equal, all the angles are equal, 90 degree. So it is a square. Okay. So ABCD is a square. Okay. Hence proved. Then the last theorem of this part, then all the theorems will be over. Okay. Next part we will move to examples. Okay. I will advise you to remember all these theorems, understand, practice and remember all the theorems. Okay. So total there are 14 theorems. This is 13th theorem. I will give the last theorem. So theorem number 14. Okay. Theorem number 14. Last theorem. Now this theorem is also based on square. We will get from rhombus. Okay. The previous theorem was if one angle of rhombus is 90 degree. Okay. So now we move to if diagonals of a rhombus are equal. Okay. If diagonals of a rhombus are equal, it is a square. We had a similar theorem for rectangle from parallelogram. If diagonals of a parallelogram are equal, then it is a rectangle. Similarly, if diagonals of a rhombus are equal, then it will become a square. Okay, so let us prove this last theorem. Let us draw a rhombus in which diagonals are equal. Actually, in a rhombus, diagonals are not equal. One is bigger, the other is smaller. But if they are equal, then it will become a square. A, B, C, D. This is a rhombus. It is not given that it is a square. It is a rhombus still now. Okay. But it is given that diagonals are equal. So let us join AC and BD. AC and BD. Diagonals are equal. Okay. So given ABCD is a rhombus and AC is equal to BD. AC is equal to BD. This is given. To prove ABCD is a square. ABCD is a square. Okay, we are going to prove this. It is a rhombus, diagonals are equal. We will prove that it is a square. So let us go for it. Let us go to proof. Proof. Already it is a rhombus. All the sides are equal. Okay. If anyhow we prove that one angle is 90 degree, then it will become a square. We don't need to prove that each angle is 90 degree because we can use theorem number 13 here. By theorem number 13, if a figure is a rhombus and one angle is 90 degree, then it is a square. Okay. We will try to use that theorem here. So my target is not to prove that each angle is 90 degree. My target is to prove that one angle is 90 degree. Okay. For that we need congruency in triangle ABC and triangle BCD. Look at the two triangles ABC. Okay. ABC, BCD. Okay. Look at the two triangles carefully. We'll try to do congruency between these two triangles. We can write AB is equal to CD. AB of triangle ABC is CD of triangle BCD. Why? Because sides okay, rhombus are equal. Okay. Next, BC is equal to BC, which is common. You can see the diagram. BC is common in both the triangles. Okay. But here also BC, or in the triangle, or in the figure. Okay. So BC is equal to BC. Next, ABC means AC. AC is equal to BD. AC and BD are the diagonals which are equal. This is given. This is not a property of rhombus. Okay. So AC is equal to BD. This is given. So by SS side, these two triangles are congruent. ABC congruent to triangle. Let us get the order. Angles are not there. Don't look at the figure. There will be confusion. Okay. Look at here. ABCD. AB opposite C. CD opposite is B. So C corresponds to B. C corresponds to B. C third means B third. Then BC. BC opposite is A. BC opposite is D. So A corresponds to D. A first, then D first. What is the last option? C here, BCD. So C. Last option is C. So this is by SSS postulate. Okay. So now I can say angle ABC is equal to angle DCB. 1, 2, 3, 1, 2, 3. Okay, means these two angles are equal. ABC means this angle, DCB means this angle. Okay, these two angles are equal by CPCD. By CPCD. Okay, let it be X. Next, angle ABC plus angle DCB is 180 degree. Okay, this angle plus this angle is 180 degree because they are allied angles or co-intelligent angles. These two are parallel. Okay. So here we can write allied angles. Okay. What is ABC? X. What is DCB? X. X plus X is 180 degree. 2x is 180 degree. X is equal to 90 degree. That means angle ABC is 90, angle DCB is also 90. One is sufficient, so I am taking one. Let us take angle ABC. ABC is 90 degree. So now we can write ABCD is a rhombus. This is given. Okay, it was given. And angle ABC is 90 degree. Just now we have proved. Okay, just now we have proved. If it is the rhombus and one angle is 90 degree, then it should be a square. So ABCD is a square. Okay, ABCD is a square. So these are the 14 theorems. Okay, in 3 parts I am given these 14 theorems. So you have to understand, practice and memorize all the 14 theorems which will be necessary for you. Okay, so I hope you have understood all this. So practice. Thank you for watching.